This is question 4 from the 2010 exam. We need to write down the first tableau of the simplex algorithm and then point out the entry that we would pivot on. We do not have to solve this LP problem. The first thing we need to look at is if the problem is a maximize or a minimize problem. We always want to start with a maximize type of problem, so we need to write down the problem in its canonical form. To do that, we need to turn minimize into a maximize problem. Minimize z is the same as maximize minus z. So we're going to have maximize minus z equals minus 4x1 plus 3x2. And then the only constraint that needs to be rewritten in its canonical form is the first one. So we're going to multiply that by minus 1, and we're going to have minus 2x1 minus x2 is less than or equal to 4. Now we need to introduce the slack variables, and we do that in order to turn the inequalities into equalities. So for the first one, we're going to have minus 2x1. Remember, we changed that one, so we need to work on the one that we changed. So we have minus 2x1 minus x2 plus s1 is equal to 4. Then we have 3x1 minus x2 plus s2 is equal to 6. And then minus 5x1 plus 8x2 plus s3 is equal to 7. And then lastly, we rewrite the objective function as minus z plus 4x1 minus 3x2 is equal to 0. And we do that because when we doing the simplex algorithm, we basically start from the origin and then move to the other corners of the feasible region until we find the optimal solution. Now we need to put our coefficients into our initial tableau. First, we have our variables. So we have x1, x2, s1, s2, and s3. And then we have our basic variables, which are the slack variables, s1, s2, and s3. So the coefficients of the first equation are minus 2 for x1, minus 1 for x2, 1 for s1, and 0 for s2 and s3, and then 4. And we do the same with the others. So we have 3, minus 1, 0, 1, 0, and 6, and then minus 5, 8, 0, 0, 1, and 7. And lastly, we put minus z for minus 3 and zeros. And this is the initial tableau of the simplex algorithm. Now, to find which entry we will pivot on, we need to look at the last row and find out which one is the biggest negative entry. Since we have only one negative entry, this is the column that we will pivot on, and this means that x2 is our entering basic variable. And now we need to find the smallest positive ratio of the resource value over the value of the column of x2. Since we have only one positive entry, this is going to be the entry that we will pivot on. And that means that s3 is our departing basic variable. And that is it. We have our initial tableau, we're going to pivot on 8, and that is all.